Exercise 26, we're still on special senses. This is with the final two, olfaction and taste. Olfaction deals with smell. Both of these are classified as chemical senses because your receptors are responding to chemicals that are going to be in aqueous solution. So smell is referred to as olfaction, taste is gustation. Olfaction, where are the receptors going to be located? Well, they're on the roof or the top of the nasal cavity. When you sniff, you ever wondered why you sniff when you want to smell something really well? It's going to draw in more air and it's going to swirl around in the upper portion of the nasal cavity, stimulating those receptors. What are the receptors? They're ciliated bipolar neurons. Whatever it is you are smelling needs to be in a gas form and then gets dissolved in order for the receptor to be able to pick it up. The neurons, the olfactory neurons, do have quite a range of sensitivity for different chemicals. This diagram is just showing at the bottom. When you inhale, the airflow would be that kind of turquoise color, the air flowing by. And you've got the mucus along the nasal cavity and it's going to stimulate those olfactory hairs. And then that stimulates the olfactory receptor cell, which is then going to move on up and eventually lead by the olfactory tract to the portion in the brain, remember in the cerebrum, that is going to then analyze and interpret the information coming in. So the track is the olfactory receptors being activated, the olfactory bulb, then the mitral cells, then the olfactory tract to the olfactory cortex. Now it is going to go through the limbic system. And remember, the limbic system is associated with emotions. So that is why you tend to have some type of an emotional connotation with smells. Either it could be good or it could also be bad. So this is just a brief diagram showing the process of how whatever that chemical is binds to the receptor, and then that triggers actually an influx of sodium coming in, which is going to cause depolarization, and that's your stimulus now. Gustation, the sense of taste. Your taste buds are the sensory organ. Most of these are going to be located on the tongue, and they're actually a little bit below the surface of the tongue. So food has to be dissolved in liquid before it can stimulate those receptors. So that's one of the purposes. Saliva is going to start, as you know, the digestion process. And then it's also helping to moisten the whatever food you've taken in, and then it's helping to dissolve it so you can actually taste it. There are 5 different taste sensations: sweet, sour, salty, bitter, and umami. The nerves for taste are also going to pass through the limbic system, so you're also going to have an emotional context with taste as well. And it has been estimated that about 8% of taste is actually smell, because both of these go through the limbic system. That's going to give the emotional context to it, once again, good or bad. But I would challenge you to think of a food item. If I were to ask you to think of a nice juicy steak, and if you had to describe the taste of a steak to someone who's never had steak before, can you do it without thinking of the smell? And you probably can't. This is also explains why when you have a cold and you're congested, your sense of smell is affected because you're congested. You may often be breathing through your mouth now instead of through your nose because of the congestion. The receptors for smell are not in the mouth. It's in the nasal cavity, so you're not stimulating them. And so you may have noticed, yes, when you have a cold, your sense of taste also seems to be altered. Has the taste receptors been changed when you have a cold? No. It's probably because you're not breathing through your nose. Once your congestion's cleared up, once you've recovered from a cold, then it's like, oh, wait a minute, now food is starting to taste good again. This is showing the location on the tongue of where the various taste buds are located. As you can see, sweet tends to be more on the tip of the tongue. Salty's right behind it on either side. Behind salty would be the sour. Notice that bitter is at the back of the tongue. And part of the reason for this, you also have a gag reflex. Bitter taste, the back of the tongue, often trigger the gag reflex. That's actually a survival mechanism because a lot of natural poisons have a bitter taste to it. So if it's very bitter, it's that survival mechanism of, maybe I shouldn't be eating this, ingesting this. The next pictures do show how the taste buds are actually below the surface of the tongue. Like I said, they're in like these little pits, and you have to have the substance dissolved in liquid in order to taste this. One easy way of doing this, if you want to experiment at home, is if you take just some sugar, whether it's a sugar cube or whether it's a teaspoon of sugar, in solid form, and put it on your tongue and see how long it takes for you to be able to taste that sweetness. Versus taking, whether it's a soda or something that has sugar dissolved in it already, and then taste that. You should be able to taste it much quicker in the liquid form versus the solid form.